its little silly games again. Now I'm on the ground trigger there, which got that weird voltage on. If I actually apply a ground, perfect ground, the issue stops. We really do have basically some weird shorting transistor inside the engine ECU. It's finally come out in Finland, dead happy about that. So I haven't done a video for a while, been busy, a lot of stuff on, but never mind, let's get straight to the point. So this particular car has come from a main dealer. Surprise, surprise, I've had a lot of lovely main dealer bad misdiagnoses. In fact, one the other day, what she said was a main battery cable, but ended up being a ground. Even though they put a new ground on, but that I didn't video. This one I'm going to video. So what is it? Well, basically, it's an F10. It's a 535D N57. Quite nice. It's all in finish, of course. What's wrong with it? Basically, cut a long story short, 20 to 60 minutes after driving it, it says it goes into neutral, which it's flashing in neutral now, and it cuts out and it doesn't start. It was told to a main BMW dealer in Helsinki area. It's shown on the iDrive, brake system fault, 4x4 fault, parking brake, clutch temperature, etc, etc. So they reckon it needs a new engine ECU, DDE, digital diesel electronics. Maybe, doubt it, but let's see. But they still don't know what's wrong with it, but they recommend we change that first. Well, that's not really what we're going to do, is it? We need to, there must be a way around it. So fault codes: 274900 DDE main relay switches off too early or under voltage. So straight away we've got a problem with DDE relay. If that ain't working, there's no power to the engine ECU. It won't work, cut out, won't start again. Temperature sensor, hot mode 3. Excessive temperature with possible damage to transmission coolant. Line detected. Possible damage to transmission coolant line detected. That's strange, never seen that one before. Wake up line type battery sensor, IBS, short to ground or open. That's it. So my young mate, who's on holiday at the moment, only spent an hour looking at it. Relay was changed, didn't work. After that, there was no comms to the engine ECU. Could be that we've got a wiring fault to the relay. Relay doesn't work, etc. But when this happened, we had no comms to the control unit EKPS as well. We need to look at wiring diagram. My friend then measured the wake up signal to the DDE, the ground, and the voltage. It was all okay at time of test, but again, if it's an intermittent fault, you know, it might be okay at time of test. The fault went away, unfortunately, because it's intermittent, it's sporadic, before he could measure with the oscilloscope the CAN bus. The engine ECU has at some point been opened, but Eric has also said that we should be putting a new DDE on it, but we need to look at this. This is a very interesting job. Could be easy, could be difficult. Let's get into it. Now, basically, all these wires we don't have a voltage drop on, but we do have a voltage drop on our ground supply, which doesn't go to ground. It's transistored, it's a digital switch, and it's switched digitally from the DDE. So it's pretty difficult, this actually, this job. In fact, it's a pain in the bum. It's been to a BMW dealer. I've had a lot of them lately. Not anything bad about dealers. I worked in a dealer myself, but some of them are shit. They don't know what they're doing, some of these mechanics, quite clearly. The only thing I've found so far, bearing in mind this is a sporadic fault, so it doesn't happen all the time. It was here last week and it wouldn't start, then it'll start for days, no problem. The only thing I've found on this particular wire here is that's a voltage, but don't worry about that voltage. The ignition is actually off, but Thomas is now going to put the ignition on. I'm going to show you basically what the situation is. When the ignition goes on, the DDE energizes a ground on that. But can you see, there's a huge voltage drop on that. It's almost 1 volt drop, 0.85 of a volt. To me, that's too much. Start the engine, please, Thomas. Okay, switch it off. There's something going on there. I haven't got another to compare it against, but I'm pretty sure, even though it's a digitally switched, transistorized switched ground, I'm pretty goddamn sure that's the reason. I reckon when it's getting hot, I think the resistance value is increasing to such a point where it's going to disengage the solenoid. Because this is a very simple relay, as you can see. terminal 85, which you can just see there. There's a resistor, then there's the actual solenoid above it. That terminal 85 is the blue and white wire, the one we've just been looking at there. In my opinion, because it's the thinnest wire, either that one or the terminal 86, which is kind of a little bit hidden. But terminal 86, which is this one here, the next thickest wire, that's kind of thin too, but it's really not that thin as you'd be an issue with it with corrosion. I think it's not corrosion. I think pretty much essentially the reason for this is this transistor is breaking down under load, it's getting hot, and the ground is just dying on it. But we don't know that because every time we try and test the bloody thing, it starts. So what I'm going to do is I'm going to do the same. The power probe is excellent, but it's not as accurate as a fluid meter. So I'm going basically negative to negative. I'm doing a classic voltage drop. Now it's a transistorized circuit, it's not always the same. But at the end of the day, not under load, if we've got a drop, we've got a problem. We need to compare it with another car, but to me you shouldn't have almost 1 volt on the ground. So there you are, we've got 925 millivolts, which to me basically means we've got resistance on that. Either we've got resistance on the wire, probably very unlikely, but we can check that quite easily. The next thing we're going to do, because really I think we should have 0 volts, kind of like that. As the car's running and it gets hot, in my opinion, that is going to probably go to 1, 3, 4, 5, 6 volts. And the reason for that is that there's resistance building up, or the transistor itself is breaking down. Now, in a minute, I'm going to disconnect it from the relay here, and I'm going to disconnect it from the DDE, and I'm going to get a halogen bulb. I'm going to make sure it doesn't go to any of the circuits first, and I'm going to power that up, and I'm going to see if it can hold a halogen bulb. And what I'll do with that then is I'll also do a voltage drop test, because when we can load it with something like that, we might see a bigger voltage drop than 1 volt. So we'll do that next. Okay, it's just started to fault now. Look, it's clicking. Can you see? There's something very wrong there. There's a weird voltage, and we've not been able to find it. I was just about to tell you. I'm gonna there now. It's okay, is it? It's randomly doing weird stuff. This. It's weird, that, isn't it? Can you hear that clicking? And that can only mean there's a malfunction in this control unit. Right, we need to do a quick voltage drop on that now. So you can see now, there is no voltage drop. So it's like some sort of a control line, isn't it? So bearing in mind, the ignition's off, but it's clicking like Billy all there, isn't it? Now, we've got a fuse here. What if we disconnect the fuse? Yeah, it goes away when we disconnect the fuse. Okay, guys and gals, really exciting news. I was just managed to trigger this. I know exactly what's causing this. Fan-bloody-tastic. So, this is amazing. I realised when I was testing, I didn't look back at the video, but I thought, wasn't terminal 87 output, the power supply for the engine ECU, wasn't that active? I think it was. I need to go back in the video and check. So we've got the terminal 86, which is completely normal, that's good. We've got terminal 85 ground with voltage because the ignition's off, that's normal I guess. Should be ground, we've got a voltage drop as we know. But we've got this one here, terminal 30, that is also okay. But what about the output to the engine ECU? Well, that's normal, we've got a ground, but watch this. By the way, that's normal because we have a voltage on the ground trigger because the engine is not active, the car is asleep. That will then turn to the ground with the 1 volt drop on. When that is a ground, of course, then this will switch over to this, and this one will become, of course, terminal 87 output active. But look, watch this. This is going to blow you away. If I trigger it very quickly with 12 volts, that's our fault. It did it itself before, and I've managed to trigger it. Yeah? Now we've got 12 volts output, haven't we? And this really weird voltage on the ground. And it's doing that because there's not enough voltage on the ground, of course, to click the relays. It's going like spazzy mode. It's gone like frigging weird, you know? Terminal 86, terminal 30. So what the hell is going on? And why is that happening? Very strange. So something is back feeding voltage from the engine ECU here to here. On this particular engine, it's pretty hard to find exactly the right wiring diagram. It says O engine T, M plus T, I haven't got a clue. It's weird, everything's got hot, you see. You see this wire that's like pink and blue? That's not pink and blue actually. You pull it out at the bottom, it starts to go white and blue. And to me, and you can, by the way, comment in the description, in the comment section, sorry, what has happened here. To me, that's been frigging hot as that. I think that's got hot. Now from what I can work out, this is the power supply from the relay. There's kind of 3 power supplies, but from one point, terminal 87, and they are actually the same colour. It's sort of white and red, then it goes to the fuse, and the output of the fuse is it's like this blue and red here, or red and blue, sorry. Then it goes to a thinner gauge here, and there's 3, can you see? So it's basically a thick gauge, and it goes into a big crimp, which is one of these here, just that one there you can see. It's a freaking great big crimp there. And then they end up essentially going directly to the DDE here. So there's your wake up. Now the weird thing about this is, now when you don't have a ground, you might have a voltage on it, but this isn't that type of ground, this is a digital ground. But guess what, for some weird reason, we still have that bloody voltage. Could that be our reason? Have we got some weird wiring fault on this particular vehicle? Because we've still got a voltage there. Now if this was a ground, like a ground point, like maybe this, and there should be a ground and it's loose or missing, you might get 12 volts and you wouldn't get a ground like that. But this, according to that, is a dead wire, so either we've got that is touching a positive wire somewhere. Maybe it's touching one of these, and that's the whole issue. We don't know, do we? But to me that should be 0 volts, that. It's disconnected there. However, it isn't disconnected here, so if we just pull out the relay and see, maybe it's a capacitance from the relay feeding back. Let's try it again. Yeah, so it was just the relay itself, or something wired up to the relay, so it's just capacitance of the relay. But you shouldn't have that, in my opinion. Is there not an issue with this frigging relay? Apparently it's been changed, but to me there could be an issue with the relay. Let me go and get another relay and check. So it's clicking away there now. As soon as you apply a decent ground to the ground that really shouldn't be grounded because the engine's off, once the ground is there, there is no issue. So that's the issue. We've got an errant voltage back feeding down the ground when the engine's off. A voltage leakage, if you like. So there's a weird voltage going on. And that is the issue with this particular vehicle. The job is getting more interesting. So my friend last time we looked at it said that randomly also it loses comms with the EKPS and the DDE. Now, that's very strange. I don't think we would need to check the CAN bus, powertrain CAN bus, I don't think. I really don't think we would need to, or PT CAN 2 actually in that case. Well, you've actually got backup line there, you see. You've got PT CAN 1, PT CAN 2. Now, I don't think we've got an issue with that at all. We've got an issue with something else. You see, if any of these were sort of shorted out and back feeding, you would think they would take the entire bus out. I think they would take everything out, wouldn't you? I think it would even go back to the ZGM and it would take all this out as well. So, something very strange going on there, right? Could be that. I will now, very quickly, scope the CAN bus. Probably the best places at the engine ECU, just to make sure, because he said that when this happened last time, yeah, it didn't happen for very long and it fixed itself. Again, we've got this weird low voltage as well. Something very strange going on with this car. I think it's been in a flood or something like that. So like I always said here, just to make sure, I've got an 100 ohm resistor there. That's why the circuit resistance is less than 60, because, you know, 120 and 120 divided by whatever. So I've got 100, that's all I've got. I've left me resistors at home, my 120 ohm resistors, unfortunately. But all we need to do is disconnect the EKPS and just check this wiring really. No, we didn't need disconnecting. We left it connected. We've got the same circuit resistance, so there's basically nothing wrong with the wiring. So hopefully it was just that pin, and maybe something else. Well, it's not a right good signal, is it, on PT CAN 2? We've got 60 ohms on it after I found that pin that was loose. So someone's been playing with this, hasn't they? But that signal is buggered. That's exactly kind of almost what my signal looked like on my i3. So resistance value is now okay, but we've got a bad signal in my opinion now. Unfortunately, for whatever reason, God only knows, I left my resistors at home I think wife was tidying up, I left him at home. But I've got 100 ohm and it'll still work with that. The trouble is, because the terminating resistor is in this EKPS unit and the other one is in the engine ECU for PT Cam 2, disconnecting this, it's going to go 120 and we lose all the signal. So what we'll do, we'll put this in place across those two wires in place of the EKPS, and we'll measure the signal, because if we've got a good signal then it means that this EKPS is pushing out a corrupt signal on the bus. If we have a bad signal still, then it's probably the engine ECU what's doing it, you know what I mean? The resistance is okay, but if you've got a dominant signal, I mean, that's just signal's knackered. I mean, it's just not, it's not going to work at that. It's pulling to ground. You can see where it's pulling to ground at the bottom there, like shorting to ground a bit. It's not going to be readable, that, to be fair. So let's see what it's like disconnected. What I'm going to do now is I'm going to kind of, by the way, that's only one CAN network. I've not really looked at the other line yet. I've got a dual channel scope set up just in case. The other one's basically exactly the same. In fact, the other one seems a bit worse. So let's disconnect this now, at least. We'll disconnect this unit now. Put our resistor in place across those two CAN lines. It'll be terrible now, the signal, because essentially there's it's 120. In fact, we've got a similar type of shitty signal, but it's even worse now because there's more signal reflection, of course. I'll show you that actually before I put the resistor on. So that's what it looks like when you've got a resistor missing. It's completely shattered and it's a terrible signal, but it's a very similar signal to what we have anyway, even with 60 ohms, which makes me think definitely we've got a corrupt, it's pulling to ground a bit as well. So that's signal reflection, that, because we've got the resistor missing. So let's put this across and see if the signal's any better. I've got a feeling it's the engine ECU. Then we'll reverse the test. We'll disconnect the engine ECU and we'll reverse it that way and put the resistor back in that and measure it again. But we'll measure it here, you know. So with the resistor in place there now, it does look like it's the engine ECU, doesn't it? Because the signal is still absolutely crap. So yeah, it does look like we've got a faulty DDE, unfortunately. It's a bit depressing, but there you are. So that's with the DDE, the EKPS plugged back in, and it's basically, if you look at the video now, I'm doing this at work, but maybe when I record it I'll do a split screen side-by-side comparison. It's more or less the same, to be fair. So yeah, not quite 60 ohm resistor, sorry, 100 ohm resistor, not 120. It doesn't matter that 20 ohm difference, you still get a good signal, you don't worry about that. So if we disconnect the engine ECU DDE, I guess we'll have, we put the resistor across that, of course, to balance the line. This resistor here, we should get a good signal on the back then, not as choppy, I hope. It's not perfect, but it's way better. You notice the top is flatter, we don't have them peaks. So yeah, it needs a new engine ECU. It's a goosed. It's as simple as that. Absolutely goosed. It's as simple as that. That's a much cleaner looking signal. I mean, you've got a bit of noise, but that's these cheap frigging bloody Think Tool cables they provide. They're not very good at all. They're crap, actually, to be honest. That's one thing about this scope. The cables are pathetic. They're really not up to fit for purpose at all. So don't worry about that bit of noise at all. I'll tell you what we'll do while we're here. Let's connect the dual channel and look at a proper CAN bus signal, shall we? Not mess around with just single channel. There we are. Should have a nice dual channel there. That's a much better signal than it. So what we'll do now, let's pull out that resistor. Yeah. And let's see if we can slow this down a touch, maybe. Not really. Anyway, that's what's wrong with the whole bloody thing. The ECU's knackered, engine ECU DDE. So the BMW dealer did a fantastic job. They actually diagnosed the engine ECU as being faulty. I don't know if they went this in depth, but still, does it matter? They've done a good job. Let's now disconnect the resistor and see how bad that pattern changes. Let's go for it. Let's rock and shock and roll, baby. Well, it's good to diagnose things properly, isn't it? Like, you know, kind of thing. Now it's open circuit. I'd have to build it back up into there, won't I? Damn. One sec. So what we're going to do now, I'm just going to build this basically back up. This is the PT Cam 2 one. I've not even checked the powertrain can, actually, if that's any good or not. You know, maybe it should be, because we don't have any issues with other units, you know, so that should be okay. Now, in theory, because this is now on the, if the DDE, which it definitely is faulty now, thinking about it, this should now make that signal absolutely terrible at the back of the car. So let's go and switch the ignition off. There we are. That's the issue. It's the DDE. Look at the state of that signal. It's buggered. It's just not the same shape. It's a bad shape. Even having said that, the serial decoding is down there. Is trying to do. But see the signal. It's awful compared to before. It's a very bad signal, is that, and that is classic CAN bus failure inside the engine control unit. That was absolutely terrible signal. Fantastic. This actual car does have evidence that it's been in some sort of a flood, like flood damage or something like that, but you never know. The guy bought this from an auction if it's the car, I think. So it's like, suck it and see, you buy it, not, you know. I mean, to be honest, like my mate, when he looked at it, it cut out, but he didn't, I think he got it going again, but then he had to go somewhere and it wouldn't do it again, so we didn't have a chance to scope it when it was faulting, you know what I mean? So you don't always get the chance to scope these. They're not always kind of faulty, if you get me. You know, it's intermittent fault like this, you don't always have the luxury of being able to scope it immediately. So, and that, as they say, is the end of that. So it's right behind me now here, and we're just waiting for authority to order a DDE. And I recorded that video a couple of days ago. This is now a couple of days later, and the car's there. It's now sort of Friday-ish now. It's just coming up to 4 o'clock, 1 minute to 4 now. So have a good weekend, everyone, and let's try and get some more fault finding videos soon. See you soon.